Let's ask ChatGPT for some exercises related to polymorphism. And I feel like using this word will generate different exercises than what we saw in the last video. I still think I'm going to have to fight with it a bit because there are a lot of ways that C++ programmers implement polymorphism or how they learn it, and they may not be the same as what we have learned. All right, so I just learned about inheritance and polymorphism in C++. I think that that's spelled correctly. My browser just doesn't know what polymorphism is. That is to say, IE C++20. Can you generate a programming exercise to give me practice with polymorphism? I'd like the exercise to involve starter code with some parts missing for me to implement. And I also really want to avoid it making me generate a bunch of tedious test cases, because we've seen lately we're working with complicated types where test cases can be pretty bulky, so I'd rather that it generated some of those for me. And I'd rather not have to implement test cases myself. That's a pretty polite way of putting it. We'll see what happens. Don't show me the solution. All right, let's take a look at what it came up with. Okay, so vehicle inheritance. That looks a bit too familiar. This time we've got vehicle and car and bicycle instead of motorcycle. Let's just skim through it and decide whether it's different enough from what was in the last video to be worth doing. We've got vehicle, so this vehicle class, unlike the one in the last video, doesn't have pure virtual functions. It does actually have, we're actually implementing functions in the base class. So that means I'd say it's probably worth doing. And then here we're overriding start and stop. Okay. And then, yeah, all right. So let's give this a try. I'm not sure that this is going to be that exciting compared to the last video, but we'll give it a try. All right, so we've got three classes: vehicle, which has a make and model. We've got car, which is a vehicle and also has a make and model, but just like last time, a number of doors. And then we've got bicycle, which has a make and model, but doesn't have a number of doors because it's a bicycle. I'm going to see whether I can get ChatGPT to use uniform initialization. I prefer to always use uniform initialization syntax, i.e. curly brackets instead of round brackets for initialization. Now, I don't want to make it sound like that actually is the difference. Uniform initialization is great for a lot of reasons, and the use of curly brackets really has nothing to do with it, but that's a good way of hinting to ChatGPT what I want. Can you rewrite the starter code to use uniform initialization? I'm not sure whether it'll get whether it's going to understand my hint, because really what I'm asking it to rewrite is a bunch of stuff in constructors. It looks like it figured it out. That's weird. So it does know that what it was doing was not uniform initialization, because when I say use uniform initialization, it does that. But by default, it would rather just use the old-fashioned initialization protocol, which a lot of people still use. So it's interesting to see that ChatGPT has that bias. Okay, we'll head back over. We're going to replace the template. I'm going to hopefully remember to do that every other time I ask for an exercise, because I really don't like having to add these curly brackets myself. All right, so we've got, I've got these two functions, start and stop, inside my vehicle class, and what they're supposed to do is just print out vehicle started and vehicle stopped. And I was hoping this would be more complicated, but it's saying, I guess, that the function's just going to be overridden by derived classes. So only if I'm working with an actual vehicle object should I expect vehicle started to be printed out. I was sort of hoping that it would be a case where I have to call the base class implementation inside of my derived class, but that doesn't look like it's the case. All right, so there's start and stop. And then display info, which is not virtual, is provided. I've got my car class here, and it just prints out car started and car stopped, which is fair enough, I guess. So I'm just going to grab these and go and, just going to bring them in here. So I don't have to use the word virtual, but I can. But I should use the word override to indicate that I am overriding behavior in the base class. I don't have to do that. It turns out it'll work just fine if I don't, but it's a good practice and a good habit to get into. And then here's the stop function. I'm going to just move this down to where it wanted me to put that. And it's going to say car stopped. And then I put the word override. Okay, so this is not, unfortunately, this is not as exciting as I was hoping it to be. Okay, and then we'll do the same thing for bicycle, and it's going to say bicycle started. I don't know how you do that. Do you put the key, is there an ignition you can put the key into for a bicycle? Bicycle started. Okay, and there's bicycle stopped. Maybe it turns out that the difficulty is just in the testing code, but it doesn't look like that's the case. And you know, because I think we're going to want a new exercise pretty quickly here, I'm going to ask ChatGPT to generate me some testing code just to get this one out the door, because it doesn't look like anything interesting is going on. This is pretty much the same level of code as the beginning of the last video. So I'm going to ask it, can you write the code for main? All right, here's a main function. Also, this allows ChatGPT to share some of its expertise on types of cars and types of bicycles. We'll see that it is now using uniform initialization as well, which I'm pleased about. Now, one thing that you might have noticed this in the videos, but if you've used ChatGPT, there is a feature in ChatGPT to set up sort of your personal preferences for how to interact with it. So some settings menu where you can add some list of statements of how you want it to talk to you. I haven't used that because I want it to be possible to some extent for you to duplicate the same things that I'm getting from ChatGPT. You can make the same requests. But probably if you were going to ask for lots of practice exercises, you'd go into the settings menu and you'd add as your preferences, always use uniform initialization, always use C++20, and never show me the solution. And that would save a lot of extra typing. But I'm not doing that because I want it to be a bit more transparent exactly what I'm getting out of ChatGPT and how. Okay, so here's our testing code. This isn't very exciting. We are creating a car and a bicycle, and then we're calling functions on them. We're not really leveraging any of the benefits of polymorphism here because all of the, other than the fact that we're able to call the base class constructor and have these two protected members, or these are private members, okay, and that there is a display info function that is not virtual, but we're still calling it. Other than that, we're not getting any benefits of polymorphism, and those benefits are not really that exciting. Like, they're not really saving us that much time. All right, so there it is. So we can see, yeah, I do starting the car started, stopping the car stopped, starting the bicycle, stopping the bicycle. Okay, whatever. Well, there's that exercise done. Now we've got a baseline. Let's ask it for something else. That was interesting. I'm being polite. Can you generate another exercise which is more challenging? In particular, maybe I'll ask it for something involving casts. I want an exercise that involves having to upcast or downcast objects. Let's just see if that helps a bit, getting a more interesting exercise. Shape hierarchy. Oh, come on. No, I'm going to skip this because we've already done shape hierarchies enough in this course. I don't want an extra. I never thought I'd say this, but I don't want an exercise involving shapes. So we'll just skip down. Okay, employee hierarchy. Okay, so instead of putting our shapes in a hierarchy, we decided to put people in a hierarchy. That's not problematic. Okay, so we're going to model an employee hierarchy in an organization using inheritance and polymorphism. We've got a class called employee and manager and developer. Okay, this is hitting close to home. Additionally, implement a tester class that derives from developer. So tester here is a role for a person. So this would be, I guess, a software developer whose job it is just to do testing, which is a job that you might end up having. Let's see. We've got employee. It's got a bunch of virtual stuff. There's a function called work for when they need to do some work. Fair enough. They have this function get role that tells you what their role is. And my impression is employee is going to be sort of the generic role. Then we've got manager, who is an employee. We've got developer, that's also an employee. And we keep track of what programming language they're using. Well, that's cute. And then I'm supposed to write my own class called tester. This is still not very different. It feels like, it feels sort of like this is still, like ChatGPT is sort of stuck in a rut. It only really has like one example to generalize from when it generates these exercises. So what are we going to do with this? Let's just paste it in and then stare at it for a bit. I think that the parts of the early bit that are exercises, if they exist, actually, yeah, there's nothing in there. So it looks like employee has been written for us. And so an employee has a name and an employee ID. Those are stored in private members. There's display info. And this, to me, is sort of the canary that tells me that ChatGPT only really knows how to generate one kind of exercise given the prompt I'm providing. All of the exercises we've done so far involving inheritance have involved this function display info. And every single time, the info has been displayed as this one-line statement with a bunch of values plugged in. And that sort of tells me that when it generates these exercises, it's probably it's being influenced very heavily by some template that it's digested from somewhere else that has this display info or something to that effect. Okay, so employee is already implemented. Manager, I'm going to do a little bit of rearrangement, some housekeeping here, just because that way it's going to fit on the screen better. Okay, there's manager. Here's the constructor for manager. It looks like ChatGPT is no longer using uniform initialization. That's sad. And so manager, you'd call get role, you get manager. This is overriding the base class behavior. So is the work function. Oh, great. Okay, so when you call work on an employee, it says employee, and then it gives their name, is working. Okay, and then when you call work on a manager, it says manager is managing the department. Okay, ChatGPT has a pretty optimistic view of how necessary management is, but fair enough. So we've got manager here, and they're an employee. We've got developer. Each developer works in a specific programming language. Okay, and I think the exercise is, I guess, to write this class called tester, which is derived from developer, so it is a subclass of developer, and the tester class should have a test method function. And then it doesn't give really any explanation of what this is supposed to be. So what are we going to do here? And then, okay, we create instances of manager, developer, and tester and display their information and call their work methods. And then this happens. So I think I get what's happening here. I appreciate that it has come up with some exercise involving upcast and downcast, but this specification isn't clear. I'm not sure what I'm going to do about this. I think I'm really actually inclined to ask it to write main for me, which in a sense is sort of cheating on this exercise because I'm not doing it, but it doesn't feel as if it's provided enough of a specification for me to do either of these two pieces without it providing something for me. It's also, I'm interested in knowing what it means by store them in an array, because although we've talked about upcasting and downcasting, we haven't yet talked exactly about what we're going to do with, like, what it means to make an array of the base class type. So maybe this is an opportunity to have ChatGPT tell us what it thinks that means. So I'm going to ask it to write main. Can you show me the code for main? And please use uniform initialization syntax. Whoops, I guess I'll just make that a question followed by a comment, followed by a statement. Please use uniform initialization syntax. Okay, so here we go. It's using uniform initialization. Yeah, this is what I was thinking it might do. It's making a C-style array. I'm going to tell it to quit that. Please use vectors instead of C-style arrays. Okay, I'm going to assume this is, it's generating the entire template again. That may not be a good sign. It might generate the tester class and I have to not look at it. All right, so I'm going to copy main. I want to stare at what it came up with because it looks like it's used something very complicated, something that's above the level of this week's material. It's basically just getting into next week's topic, which is neat. I mean, it's interesting to look at what it's doing to sort of get a hint for what we're going to see in the future, but it does render the exercise sort of moot. Okay, so we make all of these employee objects, and you can see here it's decided, for some reason, between my request for the main function and my request for uniform initialization, it changed its mind about a lot of things. It seems to have decided to use the new operator to dynamically allocate the employee objects. So there's John Smith, who works in HR, okay, Alice Johnson, who is a developer that writes C++, and Bob Davis, who is a tester that writes Java. And then we so we have this vector of employee star. So these are old-fashioned raw pointers. Now in this course later on, so I guess in the next week of material, we're going to talk about alternatives to using this style of pointer because they can be sort of error-prone and unnecessary in a lot of contexts. They are very useful in some contexts. We'll see those too, but we'll see a way around using this style of pointer in a lot of cases. So then I've got this array of employee star objects, or this vector. I then iterate over the contents of the vector. So I use this notation to iterate over them. And then I just call display info and work. This is basically what the original template was telling me to do, although the extra infrastructure involved in having these pointers certainly complicates matters. Notice the use of the arrow there because I'm working with pointers and not the objects themselves. Also notice that when I create objects of derived classes, so manager, developer, and tester, all of those descend from employee. So I'm allowed to take a pointer to manager and treat it as a pointer to employee. That is an implicit upcast. Okay, so then I iterate through the vector, I perform downcasts, and we can see here the const qualifier muddies it a bit, but you can sort of see what's happening. We're performing a downcast using an explicit cast, so static cast. And so I'm casting, oh, this is badly written. I've got some problems with this. So we iterate over the employees vector, and then we call getRole on each element and ask, is the role tester? So does this function in the object return the word tester? If so, we assume the object is of type tester, and we use a static cast. So recall that in our examples we've been doing, we've used dynamic cast when we do downcasting, because dynamic cast has the option of failing. Static cast should only be used if you are absolutely sure that the cast is going to succeed, or if you have a clear path to handle the case where the cast isn't going to work. The ChatGPT's code seems to be relying on the idea that if employee arrow getRole tells you that they're a tester, that you are allowed to assume universally that they are of type tester or some subclass of that, and therefore you can cast them to type tester and then call this method this function that only exists in the tester object. This is sloppy, and it's sloppy for a couple of reasons, one of which is if I want to know whether it's of a given type, I could use dynamic cast. That would tell me. That would be the final judge. But also because what if this particular employee was an instance of a subclass of tester, and that means it doesn't return tester as its role, but it still is of type tester. Like it still can be fill that role if necessary. In that case, this code is unnecessarily constrained. It actually is not able to function in certain more broad versions of the problem. And then I use the delete operator to delete some of these objects. So if you're looking at this and seeing the new operator and pointers and the delete operator and you've got no idea what's going on, don't worry, it's just next week's material. ChatGPT didn't know what it was doing. I think I now have enough at least to write my tester class, so just to do some part of this exercise, but hopefully you can see why I had to ask for main, because the main it was asking for seemed to require stuff that we didn't know yet. Okay, so I guess tester is a developer, so I'm going to write class tester is a developer. All right, and it's going to need a constructor, and it doesn't say, it doesn't say exactly what the tester's constructor takes, so I'm going to assume it's the same as the developer's constructor. So the tester's constructor takes a name, an employee ID, and a programming language, and then I'm just going to defer all of that stuff down to the developer constructor. So when you create a tester, you give it a name, a employee ID, and a programming language. As you can see in the tester that's been created in main, that's what's happened. Unlike in the developer class, the tester is a descendant of developer. I can just say, okay, pass all of those things, just hand them right over to the constructor of the base class. And then the constructor itself is empty. Okay, so there's also going to be this function called test method, which I don't know what it does. It doesn't look like it matters that much, but I guess I will ask it to give me a specification. Can you give me a header comment containing a formal specification for the test for, I'm going to give it state the name in explicit terms, tester : test method. Certainly, here we go. Hopefully it doesn't generate anything else. Yep, looks like that works. Let's copy this, go in here, and then see if we can figure out what it's supposed to do. So it performs testing activities for a tester employee. Yeah, okay. This function simulates the testing activities performed by a tester employee. Yes, it prints a message indicating that the tester is testing the software. You know, I really have been very impressed by ChatGPT's ability to come up with clever exercises over this series and the one I did for CSC 111. This is a case where, you know, just like me at the end of a long semester, it's clearly beginning to run out of ideas. This is not, I'm not buying this very much. Okay. Anyway, the precondition is the tester object must be initialized, but we assume that to be the case because you can't call member functions until that's happened. And the post condition is we print a message. That's not really a post condition. That's just a description of what this does. Note the function is specific to the tester class. Yeah, thanks. Okay, so tester, and I guess I'll print out the tester's name. Can I get the tester's name somehow? I call get name. Okay, so there are in the employee or the... wait a minute. So in my developer class, I'm calling this function getName, which must return the name of the employee. Where is that defined? Up in the employee class, I've got this member called name, but I don't have a function getName. So I'm just going to, let's see, I'm going to head back over here and say, where is the getName function defined? Yeah, okay. So it seems to have made a mistake in the template. It says, I apologize for the oversight. In the original code, I declared getName in the employee class, but didn't define it. Is that true? We'll scroll all the way up. Okay, here's the original class. It did not declare getName at all. It didn't declare it, it didn't define it. It doesn't remember what it did. Okay, so fair enough. This exercise is very quickly falling off the rails. What it said was, basically, I tried to define it, but I forgot. It didn't even do that, but fair enough. Here is the corrected employee class with getName added. And it's added getName, and it's neat because it's decided that getName is protected, which is fine. You're allowed to have protected member functions. It's weird because getrole is not protected. It's public, but whatever. We'll just, work with it. So there's getName. It's not virtual. It just returns the name member so that if you're in a derived class, you have some way of getting the name. So now I can call getName. Okay, so tester, and then I call getName is testing the code, I guess, and then. There we go. And then I'm going to try compiling this. I'm worried that it might fail because ChatGPT looks like it's not written the template properly. Yeah. Okay. Let's see what's wrong. Let's see. First, I don't have vector included. Okay, that's my fault. So I'll go add vector. And then we'll try again. Now we've got a bunch of problems tracing into main. So one of them looks like it is my fault. So one of them is complaining about the constructor for tester. And so for that, it looks like, yeah, that was a typo on my part. The tester constructor was accidentally private because I forgot to say the word public. And then it looks like test method is also private. That's the same issue. So I think that might be everything I need except for this is ominous, but I'll come back to this. So this issue I'm going to fix in a minute. I'm going to try running this, and then I'm going to fix that issue, and then we're going to move on because this exercise didn't really work very well. Okay, so first I make a vector called employees. I call pushback to add three things to it: a manager, developer, and tester. Once they are in the vector, all they are is employees star. And then I write employee information, and I call the display info and work functions on each employee. So there's John Smith. John Smith manages the HR department. There's Alice Johnson, who develops code using C++, I guess. And there's Bob Davis, who develops code using Java. Now, what's supposed to happen next is I call the test method function on every tester that I find. This is not a good way to decide if somebody is a tester or not, but that's what it's doing. But you'll notice it's not working. It's not printing that Bob Davis is testing the code. That appears to be a mistake on my part, because you can see it shows that Bob Davis is a developer. And the issue is, if I scroll up to the Where's developer? There it is. So there's the work function, and the work function, if I call a work function on a tester, there is no work function defined for testers, so I inherit the version from developer, and it just prints out that Bob is a developer. But one other thing I've realized is the get role function is also not defined on testers. It should return tester, not developer. So I'm going to go add that. I'll just put that down here, and I'll do tester. And then we'll save it and see what happens. This should mean, I believe, that it prints out that, yeah, it finds a person who's a tester. So this loop here, which iterates over all the employees, asks if they are a tester, and then calls test method if they are. This now works. It doesn't call test method on anybody that isn't a tester. This, however, is bad form, I think. There are reasons in practice where, yes, this does get done and yes, it does work. But the way that we're learning polymorphism, I think this is unnecessary. And I think it actually is a bit dangerous. I don't know whether it's worth, it seems like trying to fix it would require a bunch of things. But I guess what I could try doing is this. I could say const tester star t equals, I'm going to try dynamic cast. Dynamic cast to const tester star. Because it's used const in the for each loop, I'm stuck using const in anything derived from the object. And then I'll pass in the value of employee. So I'm using dynamic cast here. Now recall that if I use dynamic cast and I were casting it to something like this, so reference to tester, then dynamic cast either works or throws an exception. So it throws bad cast as the exception. And this is one reason why I'm reticent to go through this example, because this is a bit over our head. I'm going to comment out the original code here. Dynamic cast, if you use it on pointer types, let's just try it out. So I'm going to say if t is not equal to null, then I will call t arrow test method. Let's see if that compiles and see if it runs, and then I'll talk a bit about it. This warning still exists. I'm going to come back to this eventually. Okay, and then I've got this. You can see it prints out that Bob Davis is testing the code. Okay, so what did I do differently? Here I've used dynamic cast, but I haven't used it the way that we expect. So far we've seen dynamic cast used not with pointer types, not with stars, but with ampersands. If you use dynamic cast with an ampersand or not with a pointer type, then either it works or it throws an exception. And that makes sense in a lot of ways because, you expect if you throw an exception, you'll never get down below the code that caused the error. So you can't do anything wrong. Like as long as you catch that exception, there's no way you could accidentally try and use the invalid cast value. If you use dynamic cast with a pointer type, dynamic cast has different behavior. It either works and returns a valid pointer, or if it doesn't work, if it can't do the cast, it returns a null pointer. So that's why I had to write a different logic for when I'm doing a dynamic cast involving a pointer. So in this case, yeah, if it returns a null pointer, it means the thing wasn't a tester. If it returns a valid pointer, then the thing was a tester. I realize now that in my haste, I wrote a C-style initialization statement. Let's get rid of that and recompile. I can, if I want to, force this to use the dynamic cast notation that we're used to. So I could do something like this. I have to be careful where I put the const, I guess. Const tester reference t. So here I'm going to actually use a reference. The way I'm going to do that is I'm going to do my dynamic cast as usual. I'm going to say const tester reference and then give it star employee. So I'm going to go and get the actual employee object by following the pointer and then try and cast that to a tester. And then I have to wrap this in a try catch. So I try this, and then if it succeeds, so if I get to line 114, then I can call t dot test method, because t's type here is tester reference, not tester pointer. So I'm using a dot. Otherwise, I'm going to catch bad cast. And we'll just call that E, and then I'm gonna and then I'm gonna print out that this didn't work just to prove it. So let's see, unable to cast an object. I guess I'll print out their role, an object with role, and then I print out employee arrow get role to a tester. And for symmetry, I'm going to also put it here, put a print statement here. I was successfully cast. just to prove that I am able to, that if the cast works, the cast works, basically. Let's try that. And so that does work. I was worried of making a typo involving where I'm putting, like making sure it's a const reference or whatever, but it seems like I got that right. And we can see here, so here is where we run that loop. I'm unable to cast an object with role manager to a tester. So I caught the bad cast exception. And then I'm also unable to cast an object with role developer, but I was able to cast an object with role tester to be a tester. So here this is 3 different ways of detecting if an arbitrary employee pointer points to a tester. We can do it the way that ChatGPT wanted, which I don't like, because I feel like calling getRole is relying on rumors to decide whether the object is a tester. You can ask if it's a tester by using dynamic cast. The reason ChatGPT might do this is because it's learned this from elsewhere, and the reason people do this elsewhere is often because they don't want to use dynamic cast, because they view it to be slow or something, or they view it to be error prone, I don't know. I like dynamic cast. Let's use the features of the language. In my second version, I tried using dynamic cast by casting the employee pointer to a tester pointer. Dynamic cast will either return you a valid pointer or it returns null. And then in the third way, I tried doing it more like what we've done in class in this week's material, which is where I use dynamic cast with reference types, not pointer types. I still needed to do some gymnastics because I have to go from having this pointer that's in the vector to having a reference type. So I have to use star employee here. But this gave us something I think that's a lot more familiar to us. We will see casts involving pointers, dynamic casts involving pointers later on once we work with dynamic memory, but that isn't today. Okay, what should we do? I'm going to ask it for one more exercise, but I'm going to reserve the right to bail. If it doesn't give me an exercise that legitimately requires doing something new that isn't above our level, that isn't next week's material, then I'll just call it for this video and we'll hopefully get those exercises back next week and try them again. So what do I have to ask? That exercise was fine. Can you generate another exercise which is significantly different from the last 2 exercises and also somehow involves upcasting and downcasting? I'm going to have to give it a bunch of constraints. In addition, please observe the following constraints. I don't want to use pointers anywhere. Please use references instead. Okay, that's one thing I don't want to deal with. What else do I want? I want uniform initialization. Please use uniform initialization syntax everywhere. And what else? I'm going to say I want a class hierarchy that has at least 4 layers. So in this example, we had employee, then developer, then tester. That's 3 layers. I want 4 layers. I want the example to involve a class hierarchy with at least 4 levels. And then don't show me the solution. I hope this is enough to prompt it. However, the longer the prompt gets, the more likely that it generates something completely random that doesn't help at all. Let's see what it... Okay, zoo animals. Okay, that sounds good. That's definitely more interesting than shapes, I guess. We've got animal, and we've got... Oh, this is interesting. We've got mammal, bird, and reptile, okay? Additionally, there's going to be a class called fish that derives from reptile. That's neat. That's fair enough. Shouldn't bird also? I mean, if we're deciding that fish derive from reptiles, which is an unusual decision in my mind, I'm not a biologist, but if we're going to make fish descend from reptiles, shouldn't we also make birds? Okay, I don't know. So here's animal. And there's a lot going on there. Oh, they can make a sound. Okay, the animal introduces itself. Okay, this exercise is wonderful. Let's just grab it. I may need some clarifications, but this exercise, this is exactly what I wanted. We've got mammal, we've got bird, we've got... Okay, so the issue here is that this is going to require me to write a lot of testing code in main. And I'm going to ask it... So I do think I was cheating earlier when I said write main for me. What I'm going to do is ask it to write the beginning of main for me. I'm going to ask it to write these first things because that way first it can come up with all the data for it, like the color of the feathers or the name of the bird, and that should be adorable. And also it'll save me a little bit of time. Can you write the first few lines of main for me. Specifically, the lines that would implement the tasks listed as. And so I'll just paste in the comments, and hopefully it gets the drift. It doesn't try and write all of main. Okay, good. So okay, I'm going to ignore this. Oh no, that's good. Okay, so what I wanted was basically this. I want it to give each animal a name and a color or whatever, because that's amusing to me. And so, of course, the lion's name is Leo. That's what ChatGPT has learned that lions' names are. Eagles are named Eddie. I guess I buy that. Where did it get this data from? Did it like digest a bunch of like kids menus at restaurants or something? So, okay, the snake is named Sly. That's exactly the name that I would expect the snake to have. And the salmon's name is Sam. Okay, this is good. So I'm going to grab the template. I'm going to copy the whole template in. I'm really excited for this exercise to learn about all the animals. And then I'm going to go grab the main that it provided. And it looks like the main that it provided just does these two things. And then I get to do all of the other stuff. And then I'll try and read these when the time comes, these extra clarifications. I'm going to copy main. And I'm going to go over here, and I'm just going to paste it in here. I'm not sure. Yeah, it looks like, yeah, it wants me to combine this with the main and the template. So I've got this. So yeah, it just creates the animals in the zoo. So lion, eagle, snake, and salmon. And then it asks them to introduce themselves and to make a sound. And I think the way this is done, everything is implemented pretty much except for, oh yeah, okay, except for the make sound function and the entirety of the fish class. I don't know what sounds animals make. I think ChatGPT should do that for me. So I'm going to ask it to do that. What should be, how should the make sound function work for each animal? Certainly. Okay, that's not, I didn't make a request that was a yes or no question. Okay, so it's going to give me the make sound function. Okay, so I'll just paste this in. So the mammal apparently roars. That's fine. I'm a mammal. I need to learn how to roar. So make sound is pure virtual in the animal class. And that makes sense because a generic animal, we don't know its species or what sounds it makes. So I'm going to implement make sound by copying this in. Hopefully you can forgive me for this. I don't think that we're learning anything useful by writing this ourselves, although I'm learning quite a bit by asking ChatGPT to tell me what sounds that animals make. And then the bird chirps. Okay, well, I'm a bird, so I guess I have to learn how to chirp too. So we'll paste that in under bird. All right. And then the reptile hisses. Yeah, I can buy that. I'm really excited to find out what sound the fish makes. Why won't this copy? There. Oops. Okay, I'm just going to have to paste in whatever this does. Oh, yeah, nope. It copied the entire remainder of the exercise. I guess I'll just copy this one line. Okay, so there's the bird and, oh, I have to write reptile and fish myself. Okay, so I will now implement reptile and fish. Then I'm going to go down and try and do this stuff, whatever's down here. Okay, so reptile derives from animal. To me, it looks like reptile derives from animal in a very similar way to how a bird does. So I'm actually going to copy the bird class and just adjust it a little bit to create the reptile class. So I'll put it here. The name of the class is reptile. It is going to have a constructor called reptile. It's going to take as its one of its properties is, instead of feather color, it's scale pattern, which I assume is still going to be a string. I'm going to call the member scale pattern. I don't mind having a member with the same name as a parameter. And then when I get species, I'm going to say, well, it's a reptile. And when it makes a sound, it says that the reptile hisses. I think. I'll just head back over. Yes, the reptile hisses. Okay, so I'm going to try and implement the fish class before I look at anything further. So the fish class derives from reptile, and it should have a fin count attribute, so how many fins the fish has. So I'm going to grab the reptile class just because it's, it contains a lot of what I need, and I'm going to paste it in. But I'm going to say this is a fish, which is a reptile. All right, and then class fish, it's going to take a name, a scale pattern, because it is a reptile. I need to set its scale pattern just like any other reptile, but also a fin count, which I'm interpreting to be an int. So fin count, the private members of fish are just going to be the fin count. Okay, now how do I write the constructor? Well, the fish is a reptile, and the name and scale pattern are handled by the reptile class. The name is actually handled by the animal class, but the reptile class, of course, descends from the animal class. So I'm going to first defer to the reptile constructor, give it name and scale pattern. And this has the effect of calling the constructor that's been written up here. So you can see it takes name and scale pattern, and then the reptile constructor takes care of delegating that down to animal. Interestingly, it seems like it didn't use uniform initialization there. That's strange. And then I'm also going to initialize my fin count to be the fin count that was provided. I think that's the constructor for fish. I think that's all I need. Get species returns fish. And then make sound says, name the fish, and then the fish makes a sound, but I have no idea what sounds fish makes. They splash or something? They bubble. Okay, well, I guess that's sort of okay. Do fish? I guess they do, but not that often. Generally, fish somehow are able to breathe, as it were, underwater without generating bubbles, as far as I can tell. But again, not a biologist. I'm going to make the mistake of trusting ChatGPT on this one. Okay, so that's the sound of everything. I believe that that's sufficient. Like, that's all I have to do to implement the classes. So just to skim over everything, I mean, I'm hoping you've pulled this up on the side, because I can't imagine that you can see all the same, like that you've been able to memorize all the code based on me quickly scrolling through it. We have a base class animal. The animal has a name. The animal is an abstract class, which has two pure virtual functions, get species and make sound. The idea being that animal isn't actually intended to be instantiated. It's intended mostly as sort of a placeholder, a foundation to build other classes upon. It has this function called introduce, where the animal says, hello, I am, then it gives its name, then it gives its species. And there's this member name that's private. So if you want the name, you have to call a function. Then I've got mammal. The mammal has a fur color, and it roars, apparently, and the fur color is stored. I've got bird, which is not a mammal, and that is correct. Its species is bird, and it chirps, and it's got a feather color. I've got reptile, which is a reptile, and it hisses, and it has a scale pattern, and I've got fish, which is a reptile. So reptile is an animal, and fish is a reptile. I asked ChatGPT for a hierarchy that was 4 levels deep, and it didn't create one. This is only 3 levels deep. And then the fish has a fin count in addition to a scale pattern, because the fish is a reptile. And then it says it's a fish, and the fish apparently bubbles, which is fair enough, I guess. So far in main, I've just created instances of each. Oh, that's weird. I've created instances of each animal, and then I just call these functions on them. I'm noticing, though, that in the fish that it created, and this is why it's nice that I asked ChatGPT to generate some of the main code for me. In the fish constructor, it only takes 2 arguments. It takes the name of the fish, and I guess this is the fin count. But the issue is, the fish needs to have a scale pattern, because the fish is a reptile. So now the question is, what should the fish produce as its scale pattern? Now, fortunately, I won't have to ask for this, because I think ChatGPT generated for me the solution by accident, because it just can't help itself. Yeah, so here's the constructor for fish that ChatGPT wrote. Normally, I would have to ask it for this, but in this case, I'll just short-circuit it and use what it came up with. It is also deferring to the reptile constructor. It's decided that the scale pattern is smooth, whatever that's supposed to mean. And notice how it just passes in this string. It doesn't take the scale pattern from outside. I'm going to do the same thing. So you don't give me a scale pattern if you're calling the fish constructor. Instead, all fish have the same scale pattern, which is the word smooth. And now I should be able to compile the code. Okay, it does compile. I try running it, and what does it say? Okay, so it prints out all the zoo animals. I am Leo, a mammal. So Leo's obviously a lion, yeah, okay. Leo the mammal roars. I'm Eddie, the bird chirps. That's not very intimidating, Eddie. You're an eagle. I mean, that's, eagles chirping that's not very majestic of them. Okay, I am Sly, a reptile, and Sly is, of course, a snake. And then Sam, the fish, bubbles. All right, so we've got all that stuff. Now, what's the remaining exercise is to do some upcasting and downcasting. let's see. So this isn't going to do that much, I think. It's just, I don't know, like some practice, but that's fine. If I go to look at introduce, so introduce is a non-virtual function. And normally when you do an upcast and call a non-virtual function, interesting behavior can result. That isn't going to happen here because none of the classes below have attempted to override introduce. And so there's not going to be any weird clash of behavior, but it's useful to know how to upcast. I'm going to, it says call introduce for each animal. I feel like that might be a lot of code to write and not much payoff, but okay. So I'll write animal, I'll just do, I'll call it like AL. This would be the animal version of the lion. That is, oh, it has to be a reference. So I'm going to make a reference of type animal reference, and I'm going to initialize it to be a reference to my lion, which means AL and lion are referring to the same variable. However, AL, as far as you know, is just an animal, so you can't call functions that are specific to lion on it, or specific to mammal, because lion is actually an instance of mammal. And then I call lion.introduce. Maybe I'll put a little print statement here that says this is part 2. Okay, and then I'll do the same. I guess I'll do it for all of them. It seems like this is a bit sort of boring. Like I'm not getting much out of doing it like this. But here's my eagle cast to an animal. So eagle is a bird, and then I call I should call al.introduce to prove that when I do this, it still does say I'm a lion or I'm a mammal. ae.introduce, and then animal reference, this would be a S, which is the snake, and I take my snake variable and I make a reference of type animal reference to that, as.introduce, and then finally animal reference AF is the fish, and that would be, I take the salmon for that, and then AF.introduce. Okay, so I'll try that. This is doing upcasting, so fair enough. And ChatGPT knew I wanted upcasting exercises, and it gave me something that was pretty bland, but it did give me something. And we can see here that even if I'm casting them all to animal reference, when I call .introduce, it still knows that Leo is a mammal, Eddie is a bird, Sly is a reptile, and Sam is a fish. Now, while we're here, we might as well play around a little bit with syntax. So when ChatGPT wanted an upcast, in the last example, it generated a much more verbose thing. It used a static cast. So I could try that out. So remember that static cast works if you should use static cast in cases where you are certain that the cast is going to succeed. That is, you've already worked around the situation where the cast will fail. If a static cast... the idea of a static cast failing it's sort of a misuse of terminology because the static cast is a code that is written at compile time, basically. So static cast can't really fail, but it can generate a result that makes no sense, where if you try and use it, weird random stuff will happen and the program will probably not work properly. So you should only use a static cast if you're certain that the operation will succeed, or if you have in some other way insulated against the operation not making any sense. So here I'm doing a static cast and I'm taking the value of the lion, and we can see I call static cast and I give it animal reference as what I want to come out of it, and then I give it the thing I want to perform the cast with. You're allowed to use static casts to do downcasts, and in fact in the last exercise we saw ChatGPT doing that. So I'm going to go back over to the last exercise. In this version here, where it said, if the employee says it's a tester, then I'm going to static cast I'm going to do a downcast with static cast. This is dangerous. It worked in this case, but I considered it to be a bit flaky, because if somebody accidentally returned the word tester when they weren't a tester, this would result in the program probably crashing or something really weird happening. So static cast should generally be used for upcasting and only for downcasting in very weird specific cases. So I could also do it like this. I generally prefer to write upcasts implicitly, unless the writing static cast helps the reader to understand what I'm doing. In this case, I think it's sort of obvious. I'm casting to a base class type, so it's pretty clear that I'm doing an implicit upcast. So that's my preference. That it's just a matter of personal taste. All right, the next thing is I downcast objects to their respective derived classes and then display additional attributes. That's weird. The reason I'm saying it's weird is I'm going to do a quick tour through all of our classes. There's animal. Notice how the only functions are the ones that are pure virtual plus introduce, and then a private attribute name. If I look at mammal, it has a fur color, but there's no function to get the fur color. I've got no way of retrieving it. So I guess I have to write, if I want to print out the attributes of animals, I have to write something that allows me to do that, which is sort of weird. And then I've got class bird, same story. Where do I get the feather color from? And then there's reptile, and then there's fish. So I guess to do I want to do the exercise, so I guess I have to go write that. So I'm going to say get fur color, color with OR. I guess I have to live with it. The template says what the template says. Return fur color. And then if I copy this, is it any faster? Oh, this should be constant. So ChatGPT has been careful to ensure constant correctness, so I'm going to try and do that myself. Okay, and then the bird has a feather color, so I say get feather color, and then I return feather color. The reptile has a scale pattern, so I'm going to get scale pattern, and then return scale pattern. And finally, the fish has a fin count. And so I'll say get fin count, and that's going to return an int. And then I return fin count. All right, there's a lot happening there. Let's just compile to make sure I didn't make a typo. It looks like I didn't. So I want to do a bunch of downcasts. All right, so I guess what I'll do is I'll take these upcasted versions I had from earlier and try downcasting them. It doesn't say exactly how many of them I'm supposed to do, so I'm not going to do all of them. I'll just do a few. I'll just do one or two. Okay, so I'll start with, let's recast the mammal back to, the animal back to a mammal, the lion. So I'll say mammal, the lion is set to, okay, here I'm going to do a dynamic cast. Now, interestingly, I could do a static cast here and it would be safe as long as I am sure that the thing that I am casting from actually is a lion. And maybe we can try that out. So here I'm going to say dynamic cast of this, of AL. So AL is an animal object that happens to also be this lion from earlier, which was a mammal. So if I cast AL to a mammal, the cast will succeed because it is a mammal, period. Like, there isn't any way this program could run as it's currently written. Lion is of type mammal. AL refers to the same variable as lion, so AL is referring to a mammal, which means that this cast will never fail. If I know that it will never fail, I could write a static cast. But if it might fail, then I should write a dynamic cast, and I should handle the failure somehow. I'm going to write a try catch to handle the failure here to see what happens if I swap this. So I catch bad cast. And then we do couldn't cast to mammal. All right, and then I'll do one more. So I'm not going to call this the lion anymore. I'm going to call it the mammal because I might try and cast other things. I'm going to do one more, and it says I should display the fin count for fish. So I'll try that. So I'll do fish. The fish equals dynamic cast to type fish of AF. So the salmon is a fish. I cast it to an animal, but it still is a fish. So I should be able to cast it back down to type fish, and then couldn't cast to fish. And then in the meantime, what am I going to do with each thing as I get it? I'm going to write for the mammal, I'm going to write something like the mammal dot, I'll just print out, what was it? It's fur color. So I'm going to write OUR because I have some self-respect. The mammal dot get fur color with OR because I had no choice. And then for the fish, I'm going to write, I guess it was number of fins. So I'll write number of fins, and then I call fin count. So that would be the fish dot fin count, or get fin count. So we'll try running this. This should work, and it does. You can see fur color yellow. The lion's fur is yellow. Number of fins 2. Let's see what happens if I make this fail. So what if I try casting the eagle from animal to mammal? That should fail. Dynamic cast is able to fail, and so that it will fail, and then I'll get couldn't cast to mammal. Now let's see what happens if I go back a bit. So I'm going to cast the lion again. So the lion is a mammal. I'm going to use static cast. So the lion is a mammal, and I'm casting it from animal to mammal. And static cast, as I said, is something that we can use. I'm able to use static cast for this because I am absolutely certain that the cast won't fail. And so static cast, although static cast, you could think of it notionally as failing in certain cases, we think of static cast as something that can only fail at compile time. So there are certain things you can't cast to certain other things, and the compiler will catch that and say, you can't do this cast. If the cast is possible and it could only fail at runtime, depending on the value of the variable, then we have to use dynamic cast to catch that failure. You could also say, but wait a minute, can the compiler notice whether the static cast is legitimate? That's also possible, and that is the failure mode for static casts. Let's try casting the eagle to a mammal. Notice how this is an eagle object. It happens to be masquerading as type animal, but it's an eagle object. The compiler didn't complain. What happens if I run the program? It prints out that the fur color is brown. That's interesting. Where is it getting brown from? So if we look at this, we observe that the bird has a feather color, and the eagle is a bird. And when I ask for the mammal to tell me its fur color, I get brown because that's the bird's feather color. In other words, I get something meaningless. This is not a mammal. The eagle, the bird, is not a mammal, but yet the static cast, because it's not allowed to fail, it is allowing you to pretend this thing is a mammal, which of course is false. This is actually a logical error in my code. Now, because of some interesting coincidences, it is able to generate output. The output makes no sense, but it is able to, the program doesn't crash. I'm going to go back to using the lion here. Let's go down and try the same thing with the fish. So if I use static cast to cast the fish, it's going to work because AF is a fish object. It's the result of casting my salmon to type animal with an upcast. So the downcast will succeed. We can try this, and we observe that the number of fins is 2. Now let's see what happens if I use a dynamic cast, and I try and cast the eagle. The eagle is not a fish. And it says couldn't cast a fish because it's an eagle, it's not a fish. Now let's try using a static cast. Now the static cast isn't allowed to fail in the same way a dynamic cast is. If I try running this, notice how the compiler doesn't complain, and then I try running it and it says number of fins is 0. Okay, but it doesn't. It's not a fish, although it does actually. You could argue that something that isn't a fish does actually have 0 fins, so I mean, fair enough. But in this case, what's happening is it doesn't. Static cast is resulting in random behavior. It can't let, the cast isn't allowed to fail, so what comes out will be a reference to fish, but if you try using it, you're going to get anywhere from innocuous but sort of incorrect behavior to the program crashing. Because of the way ChatGPT set up the example, it's not going to crash in this case. It's just going to sort of give erroneous output, but it could do that. And that's one of the reasons why we should use dynamic cast. We should test if our downcasts fail unless we're absolutely certain that they could succeed, because static cast doesn't check for us, and it may result in weird random behavior occurring. I think that's all I have to say about that exercise. I like the exercise, and I also like that we were able to get it to a state where it was this week's material and not next week's. I'm going to ask ChatGPT for the solution. Can you generate the solution to the entire exercise? Let's see what it did, if it's able to do this. Certainly. Okay, so we've got animal. Animal has a name. We have get name there. There's get species, make sound. This is, I think, the same way it was in the template. Here's mammal. So the mammal roars. Now, the mammal and bird classes are going to be pretty much the same as they were in the template, so we can see the bird chirps, all right. There's reptile. The reptile hisses. Here's the fish class, and it calls the reptile constructor, as we saw earlier. The fish bubbles. And then here's main. So I create my 4 animals. I call the introduce and make sound functions. And now I use implicit upcasts. That's interesting. I was expecting that ChatGPT might use static cast here, but it didn't. It used implicit upcasts. It writes them a little bit different than I do. It uses C-style initialization and the const qualifier, but both of those are fine. Those are matters of personal taste. And then it calls .introduce, and then it does some downcasts. And here it's using static cast. So these particular noun casts with static casts are valid. They're not sloppy because you do know that lion ref, which you're casting from animal to mammal, well, lion ref is referring to the variable lion that is a mammal. So you're guaranteed for this cast to succeed. However, static cast is a bit dangerous if there's literally any possibility that the thing you're casting isn't of the type that you want it to be. And then it also prints out, it then uses those to call get fur color, get feather color. These are things we would not be allowed to call on the animal references. We can only call them on things of type mammal, bird, reptile, or fish. All right, there's that exercise. And I think some of the stuff we saw in the middle exercise 2, that was a bit above our head, we'll actually see that. We'll talk about that material next week. It is just next week's material. I just didn't want to go into too much detail for it today.